Hello Year 7. Today we're going to do about reflection. So here is the file that we need. So if we go to that one, Science Year 7 Everyone, the first lesson you need is Lesson 3, Reflection. Then I want you to open up the reflection worksheet, which looks like this. And then I would like you to open up the reflection PowerPoint, which looks like that. The first task I want you to do is the worksheet Task 1 Starter. So if you want to pause the video and have a quick go, and then unpause it when you're ready to continue. Now, I do not have a ruler. So this first one, how do we see luminous objects? Because this produces its own light source, you need to have a straight line going from the light to the eye, and then have an arrow pointing towards the eye. Or maybe I should go into his actual eye, not his eye patch. The next one, seeing this non-luminous object here, you need to go from the light source. The light has to reflect off the non-luminous object and then go into his good eye. The arrow has to point towards the eye every time. Okay. So, hopefully we got that correct. If not, there's no problem, because we'll be doing a bit more about reflection today. Now, first of all, we're going to look at this. So if you want to just pause and look at the lesson objectives and then unpause when you're ready. So that's the answer to this one, which we've just gone over. Now again, if you want to take a guess, what are these things? These are images through microscopes. What do you think they are? So pause it, then unpause it when you're ready. Right, first one's toilet paper. Second one's laminate flooring, or wood flooring. This is a kitchen surface, and then this is a glass. As you can see, all four of these things are different in their texture on the surface, and all four of them are not as good as each other at reflecting stuff. So the toilet paper here is quite bad at reflecting things, whereas the glass and the the glass and the worktop is pretty good. Now this is the reason why. If you've got a mirror, what you'll see is you've got this flat surface, okay? You've got a nice flat surface for everything to reflect off of. So every light ray comes in and bounces off this mirror at exactly the same angle as it came in, right? And now you can see on the bottom one with the paper, you can see what's happening. So the mirror, everything comes in and it goes out, comes in the same direction, goes out the same direction, everything's nice and neat. The paper, it kind of comes in, and then depending on where it hits on the paper, it reflects at a random angle based on what it touched, right? Now this isn't a very good reflection down here. This one at the top is. We actually have a special name for this. This is called specular reflection. So if you have a look in a mirror, that's what it'll be. And this bottom one is called diffuse scattering. Now, to form an image, you need to have this top one here, specular reflection. Okay. Now, again, next time you go look in the mirror, like this person here is doing, she touches her nose with her left hand, but she sees the reflection in the mirror. So whenever you see a reflection, it is reflected and everything is kind of flipped. This is the one reason why when you look at yourself in a photograph, you always think you look a bit weird, because you're used to seeing yourself the other way around. Now, we will skip past this because I want to more go on to sort of a practical. So I'll read it out. When you look in the mirror, you see a virtual image. This image is the same shape, size, and distance that you are from the mirror. And when you close your left eye, the image appears to close their right eye. Now, we are going to do, or at least we're going to try to do, some sort of practical. If you don't have the stuff at home to do this, that's absolutely fine. You can always just go on YouTube and have a look, or you can just trust me. Now, when we do reflection diagrams, it's very important there are a few things. The mirror is straightforward. Usually the mirror is drawn for you, but this is not always drawn for you. This is called a normal line. Okay, this here, this dotted line is called a normal line. this line is at a right angle to the surface. And remember, a right angle is 90 degrees. Now let's say I've got a light ray that comes in like that, and it touches the mirror exactly where the normal line is. If I was doing the practical here, what I would do is, if this was my light ray, I would put little X's along the light ray so that I can join the dots and create a line, so I can then measure what we call the angle of incidence. Now, this light ray is coming into the paper, so I call this the angle of incidence. So this light ray here is coming in, so it is the angle of incidence. So this angle here, right? Now the practical that we would be doing is measuring what is the angle of reflection. So something is going to happen over here and the light ray is going to bounce off, but what is this angle here? Now in order to do this, I'm going to show you. So discard my ink and let's swap over to this. All you will need for this is some sort of light, so I'm going to use my phone. You'll need a mirror, which I don't have. It's on the wall in the bathroom, but if you've got a handheld mirror, that's perfect. If not, you can try and go into the bathroom. In the files there is paperprojector.pdf. If you can print that off, that's perfect. If not, you'll just have to do it by eye. I have got a piece of paper here and if I shine my torch on the back, you can see I have got kind of, well, actually you can't see it very well. I've got a hole just here, and then I've got a line just there, right? So what I would do is I would turn the lights off, I would shine my light through this like sort of slit here that I've cut using scissors. Okay, so I'll put it a bit closer so you can see. Yeah, there's the slit, right? And then the hole. And then you would shine it along a table and you'd see a straight line. If you put a mirror there, you can see it reflect back. Now, if you can also print out the paper projector, you can measure the angle. If not, you'll just have to trust me when I tell you that the angle coming back is going to be the same as the angle going in. So, this angle of reflection here, okay, this angle of reflection is going to be the same as the angle of incidence. Now, I want you to go and finish your worksheet once you've done this, so you should have, if you could do the practical, you've got some measurements. If not, just fill in the blanks. Now, there is also an extension, the Treasure Island one. You'll need a ruler and you'll need some sort of way to measure an angle and see if you can solve that puzzle. It's quite a difficult one. See if you can do that, it's very good. But if not, we are going on to this next task. Okay, what's wrong with this picture? Hopefully you noticed that this bit here is wrong. This is a luminous object, as in it is emitting its own light. So for you to see that object, the light has to go towards your eye. Okay. What's wrong with this picture? So again, just pause it, have a think. If you're ready to go, unpause. Well, light travels in straight lines, but it can't bend around the wood. If you had a block of wood between you and a candle, you wouldn't be able to see it, right? The light ray should just go straight into the wood and be absorbed by the wood there. You would not, the light would not bend around, okay? If you want to know what this actually looks like, go Google what a black hole looks like, because very funky stuff happens there, and light can bend, but only in very extreme conditions around black holes. So if you want to see what it would look like if this were possible, Google what a black hole looks like. Now this one here, what's wrong with this picture? Hopefully you saw that that's not correct. The light source here emits the light, it goes through the glass, okay, and the arrow goes towards the eye. What's wrong with this one? Again, hopefully you noticed it was that, and the light ray goes to the mirror, it reflects off the mirror, and it goes back to the eye. Again, what's wrong with this one? hopefully you should realize that there wouldn't be a light ray at all on this side of the wood because it is absorbed by the wood, okay, because the wood is opaque. Now that is pretty much everything. We can't do the light boxes yet, and we might try them at a later date, but after you have done your worksheet, and if, okay, so that's the worksheet. If you want a challenge, here's the Treasure Island task. Okay, you'll need a ruler, and you'll have to, you see the mirrors are here and they reflect off the mirrors. You have to figure out where it goes. And here is your paper protractor if you have access to a printer and you want to try and do the practical. What you need to do after you've done the worksheet, and could you email that back to your teacher, please? Okay, see you tomorrow.